So hello everybody. Today we're going to talk about biometrics in our everyday lives. So today we will cover a brief history of neural networks, computer vision, that's how computers actually see everything around us, biometrics using smartphones, active and liveness passive detection, and a quick demo. Now, before we start, I just want to remind you that computers only do what you tell them to do. Computers don't have feelings and emotions. So with that in mind, I want to ask you this question. Where does artificial intelligence then actually come into play? The history of neural networks, where did all this start? So it actually started with something called neural networks. And the neural networks simply mimic the behavior of the human brain and how it processes information to make decisions. Neural networks actually consist of nodes, and that's similar to the neurons in the brain, to recognize patterns and relationships in raw data. This is cool, but what makes neural networks so special and why am I talking about it? Neural networks can't only find patterns and relationships in data, but it can also learn to make smart decisions. So neural networks are essentially algorithms that are used in machine learning to enable computers to make predictions. Now, these predictions are what we say, this is how we classify computers to make decisions. It's actually just predictions. So yes. So neural networks actually started with these two guys in 1943. And it was due to a famous paper that was published in 1943 called A Logical Calculus of the Ideas Immanent in Nervous Activity. The gentleman on the left is Warren McCulloch, and the gentleman on the right is Walter Pietz. And they were the first to actually describe how neurons in the brain works. And to prove their findings, what they did was they actually simulated a neural network using electrical circuits. And this was ironically the same year that the first computer was made, according to my research. So it wasn't until 40 years later, actually 4 generations later, that humankind actually started delving into this topic because it was very new and very advanced for the time. So during 1982, Japan actually announced the 5th computing generation, driven by efforts to actually understand what that paper in 1943 meant. And this, of course, made USA feel like they're behind, and they started funding these initiatives, and this is where everything actually started. So yeah, just to give you some context, during that time, this is how the computer actually looked like, and this is the whole computer. So yeah, and during the 90s, 2 papers were published. One was published by 2 Austrians and one by an American. And this finally made the humans come up with an algorithm to be able to simulate the human brain with a neural network. And this is where the era of artificial intelligence in computing actually started. So yeah, that's just a funny diagram. So the next topic is computer vision. So for those who don't know what computer vision is, that's plainly how computers see things, using cameras and all these sensors. So it is actually the ability of computers to identify real world objects. And have you ever actually thought about how computers see things? I mean, we're all used to arrays and integers and data structures and things, but how do computers actually calculate and think of these type of things? So I'm going to use a simple analogy here. Let's take a flower. I mean, humans can easily identify this as a flower. I mean, this, before I even said it's a flower, you all were like, okay, nice purple flower, but how do computers actually calculate this? And even children can identify these flowers. So how do humans actually identify this as a flower? No one told you it's a flower. This is because there's something called an evolutionary context. Through million years of evolution, our human brains are adapted to be able to understand these things very, very fast. So how do we simulate this in a computer? That's a big question here. There is no evolutionary context for a computer, but we just spoke about neural networks and how we can simulate the human brain and its activity to make decisions. This is where computers use machine learning to understand what it sees. So first, the computer sees this flower on the left, and it actually sees it as an array of integers. What are these values in this array? It's simply intensities of the color spectrum. So essentially, the computer can pinpoint these points and actually define the flower, but that's just one flower from one angle and one type of flower. So, you know, how is a computer going to identify a different flower? And this is where convolutional neural networks come into play, where computers can actually learn things and they can actually adapt and make better predictions. And these neural networks are trained, so they can actually improve. The training of a convolutional neural network, or CNN, begins by sending various types of flower images as input to the CNN. And this allows the computer to kind of create a better understanding of how flowers look from different angles, and all those different type of aspects that define a flower, right? So, but how does it remember what it sees? It remembers this by doing homework, all right? Just like kids learn, you go to school and you do your homework and you go back and then you try and understand what the math teacher told you. Here is that. So this homework is called backwards propagation, and this is where a neural network actually adjusts its error value to make better predictions. So this is mostly used for images, but what about videos? Videos are simply a collection of images, which makes the processing easier, but there's a big problem with videos in computer vision, and that is that there's context between images. So let's take this example, right? There's a box with some items and plates, and someone's busy handling those plates, right? But the question here is the person busy unpacking the box or packing the box, right? I don't even know what he's doing there, but yeah, this is where AI starts to come in. There's absolutely no way to distinguish between the two. So how do we solve for this in computing, let alone humans? We do that by using recurrent neural networks. And this RNN actually caters for temporal sensitive data. In layman's terms, it's basically catering for the context between images, which has to do with time. And this also is where humans get their evolutionary context. So the output of the CNN is used as input to the RNN. So they actually work together. And then the RNN trains itself by adjusting its error rates to make better future predictions. So just normal tools for computer vision is OpenCV, TensorFlow, CUDA, and MATLAB. OpenCV and TensorFlow is open source. So if you want to test it yourself, you can. So where does this tie in with biometrics? The answer to this talk is about smartphones, because we all know about smartphones. I mean, most of us actually have one. So in South Africa, every one out of three persons have a smartphone, and this allows for the widespread access to the web and remote access to the web. So smartphones are a big role player in biometrics. So biometrics include any characteristic of a human that is able to uniquely identify that human. So example, your eyes, or the way your eyes look. So yeah, that is a biometric. So biometrics can be captured using high-end devices like dedicated sensors, but smartphones will be discussed because that's what we use in our everyday lives. So most smartphones have built-in sensors. As you can see, I'll let you guess which smartphone this is. But Yeah, these sensors actually include a camera, proximity sensors, so for distance, infrared lighting, and infrared lens. Infrared sensors detect heat. So in a biometric scene, these sensors are not only good to prove the quality of biometrics, but also to prevent malicious users from accessing smartphones. So for example, the newer smartphones have infrared sensors, but the old ones don't. And that's just how the smartphone has evolved. Another thing to mention regarding security is that most security advancements only occur after an incident. So most biometric solutions don't say, okay, we're doing this type of verification because we hope it happens. No, they know of attackers that try this and that, and that's why they provide the certain solution that they do. So this is where the identification of real humans started prompting AI to better itself, because how can you distinguish between a real human and a fake human in a biometric scene, especially using smartphones? So this is where active and passive liveness detection actually comes into play. So the effect that COVID has had on social distancing actually led to social distancing, and because of social distancing, people started shopping from remote locations. Companies started seeing that they need to cater for identifying malicious users to lower the risk of trade from these disparate locations. So the emergence of KYC, or Know Your Customers, eKYC, and AML, or anti-money laundering, also comes into play, because I mean, e-commerce is a trend that's been going. So you don't want malicious users buying stuff and then they bypass the system. So so active liveness detection is where you simply have to blink or move your head or go like this, or raise your hand or something. And that was the first generation of liveness detection. But the second generation is passive liveness detection, and this is a very recent trend. There's only a couple of biometric vendors around the world that do this, and that is what we're going to look into a little bit later in the demo. But yeah, so how do you actually measure the standard? How do you actually measure how accurate the biometric system is? Because I mean, you need to identify real people and fake people. So how do you actually measure this? Now, you measure this using different standards, but the most popular one is iBeta. iBeta is literally a testing lab in Denver, Colorado, in the USA. That tests these systems, biometric systems, with various tests, spoof tests. So using fake masks or wax heads, and this will actually certify that biometric solution. So a spoof is a non-living object that basically just pretends to be a real human. So very interesting. There's $100,000 bounty for any person currently that can bypass a biometric company called FaceTech. They've got a solution. If you can bypass this system with these 5 levels, they will award you with $100,000 US. Now, no one has been able to do that for a couple of years now. Even the most famous hackers haven't been able to do that. So yeah, just to show you that how advanced this AI is that they actually put a bounty out there to the public. So yeah, just an interesting fact. So there are different types of biometric modalities. Just to name a few: DNA, face, iris, voice, typing, fingerprint, vein, and hand geometry. Some of these actually sound weird. I mean, how do you even measure your DNA? So yeah, it's definitely evolving into a scene where we go deeper than what we actually see. But that's very, very advanced. So the most widespread one, I mean, most of us use facial recognition, right? And that's on our smartphone. I haven't used facial recognition on my browser before. So yeah, smartphones are definitely a direction or channel for biometric security. And also because it can operate on low-end devices. I mean, I think the iPhone 6 or 7 even has facial recognition, which is quite good. So just to mention, in South Africa, we've got an act, the Protection of Personal Information, the POPI Act. It's been there since 2013, and basically all that it says is that you have to tell a person when using their biometrics. You can't just take it. That's against the law in our country. So basically all you have to do is you have to tell them that you're using it. And yeah, interestingly enough, if you cell phone numbers, so your whatever ISP you're using, your cell phone is not seen as personal information. I wonder why. So the next question is 2D versus 3D images. I didn't even know there's something like a 3D image, to be honest. So 2D images are generally weak, and they don't allow for depth to be perceived, while 3D images allow for depth to be perceived. And just to show you how powerful this is, in 2019, Facebook had to delete 5.4 billion fake Facebook accounts because of people saying that there are other people and they are not, and they had to delete these accounts. Now, this could be prevented using liveness detection. So the optimal solution for biometric service would be to use mobile onboarding using a single frame, which is faster than their videos, so like a normal image. And this would have to pass a true or false value, because intruders would be able to know which part of the system they did not pass. So you have to keep it as straightforward as possible. So yeah, 2D versus 3D images. So because biometric solutions use training models that aren't perfect, and I've actually also tested this myself with certain biometric solutions. But the big metric to look for is false acceptance rate. If your false acceptance rate is high, then you've got a bad security solution. But other caveats like ethnicities such as Africans and Asians, that's still it's just because of how the face is actually structured. And masks is a big thing, because you've only got about half your face to identify. Face coverings, such as certain cultures have to wear face coverings, and then also twins. So to show you something interesting, with the twin issue in biometric solutions, this is used. I tested this on Amazon recognition. On the left, you've got my brother, Sarel, and on the right, you've got me. Now, people say we're twins. We are actually not twins. We're actually 4 years apart. But Amazon they actually say that we are 86.5%. There's a 86.5% that we are the same person. Now, this is using advanced AI, and they still say that we are the same person. So just to prove to you that that is a caveat. And so yeah. Okay, so current implementations. Smartphones, almost all of us have a smartphone. So obviously, if you've wondered how face recognition works, so the image is usually stored locally, so that of your face, so that you can access it offline. And all it does is it matches your face with a one-to-one comparison. So it takes your face, takes the current image, and it says, is it the same person? It's as simple as that. Some smartphones don't have liveness detection cameras, and that is infrared or any other mode to identify the liveness of a person. The drivers for adoption are something called password fatigue, where humans they're actually frustrated because they have to remember passwords for this account, that account, this work, all of those things come together, and the user is stuck with so many passwords that they don't want to remember anymore. And that is a driver for biometrics, because you take a photo, you record your voice, it's quick, it's accurate, and you're in. So according to my research, The only biometric vendor in the world to have all 3 I-beta levels passed is a company in New York called IDRD, it's just because they've done extensive research in this field. So yes, and a very interesting implementation for biometrics is in vehicles. I spoke to a company in Port Elizabeth, and they said that within the next 10 years or 5 years, I can't remember, they might implement voice recognition within cars to identify people under the influence. And that meaning alcohol. So if you are under the influence of alcohol, your car will not start, and they will probably notify the authorities close to you. So just a heads up on that. And then future implementations for biometrics include RFID tags, radio frequency identification in the human body. And that they've actually done this already. I know in Sweden, they actually sell these online. You can insert them yourself using an injection. You don't need a professional. And this is quite scary if you think of this. Where's this going to end? If we've only used it for a couple of decades, where's this going? Where's this going to end? But I definitely use facial recognition. It's fast, it's accurate, and yes. So now it's demo time. So just to show you, there's a normal app. So usually you have to open an app and then you have to enter your password, right? We're all used to that. Into your email password, then you see your email, see your inbox, everything. But that's old school. I mean, really, we've been to the moon. Isn't there a faster way? So I'm simply entering my email and I'm prompted with this face selfie. So now all I do is take my face selfie. And this demo is going to show if my face is a real face or not. Right? So now you can see the face is live. So next, I'm going to move on to show you that my voice is real, right? So here I've got my other phone with the voice recording there, and I'm gonna play back the fake voice recording, and let's see if it's real or not, right? Okay, let's see.
Hello, my name is Marco. Hello.
Let's see if it's real. The voice is not real. Oh, thank goodness. Okay. So now let's say the real voice. I'm going to speak now, and then let's see if they can detect if it's my voice. Hello, my name is Marco, and I'm talking to BBD. Hopefully this will say it's a real voice. And the voice liners is passed. Right. So now you'll just be taken to your landing page. So this demo actually used passive liveness detection. You didn't see me, doing this with my head or blinking 42 times, or the same with my voice. I didn't say a certain thing. I just spoke my normal password. So yes, that's all from my side.